scale models, it is still relevant in a way to know something about Filipino because of like the tokenization or knowing something about that language you're building towards. But most of the time you can do away, with just providing large amounts of data, then just let the model figure it out. Second, in terms of size, this is quite obvious. One tends to be quite small, but right now our definitions of small definitely change. Right now, a 7 billion parameter model is already considered small. And sometimes these things are like changing as the day passes. And on the other hand, for large scale models, sometimes bigger, usually bigger is better. So more data sets, much better. Bigger capacity gives you higher downstream performance. And then finally, on utility, most artisanal models, they tend to be bespoke, meaning if you train a model for like a specific task, it's not always transferable to another. But on the other hand, you have large scale models that were usually built for general purpose applications. So some of you, of course, are familiar with things like Llama 3 or like Chat GPT. Like usually these things are very general purpose, and the way they are evaluated are also in these like general purpose tasks like chat or chat hard. Um, but again, I guess one thing I want to stress throughout this talk is that it's not about one is better than the other. I want to focus more on the merits of like these small models by discussing parts of my research and my work. So, here's the outline of this talk. Wow, conclusion kagad. So what I'll be doing is that there would be 3 bullet points, and we will be filling in the blanks. The first one is that artisanal NLP models are high effort because blank, blank, blank. And then the second one is that they're capable of doing a few things, but blank, blank, blank. And then the third one is that they may not be the most mainstream in a way, but blank, blank, blank. And then we'll be filling these things in. Ice Bayan. If you have any questions, feel free to interrupt. I am not, I unfortunately, I don't think I can see the chat, but it's fine. But you can just like ask questions right away. So, okay, let's go with the first one. Artisanal NLP resources, they're high effort but impactful for the large community. And here I will be talking about the named entity recognition dataset that I've built. So here I just want to give you a recap of like what NER is about. Obviously, most of these things you already know already. So you have a text and you wanted to figure out the named entities, right? So these things are usually like sometimes proper nouns, and then you want to kind of categorize them in terms of different labels like location ba siya, or organization ba siya, or person ba siya. Um, in This is like a very classic NLP problem nowadays, and you can argue that this is almost solved in English NER, but Tagalog still lacks the tools to solve this, diba? There's not enough annotated data, there's not enough models. And even if like Tagalog is like the majority language in the Philippines, we still consider this as a very low resource language. This is a very on the right, you would see a graph. This is a very interesting chart that I really like. This kind of like shows the state of like different languages in the field of NLP. On the x-axis, you have like the amount of unlabeled data. So think of things like websites or social media. Lahat sila unlabeled, right? They're useful for pre-training, but not necessarily for fine-tuning or for like supervised learning. And then on the y-axis, you have like things like labeled data, which, for example, for NER or for text classification, is useful for supervised learning. And then the dots here, they represent different languages. While the big numbers, yung 0 to 5, they're like regions of categories that the authors defined. So for example, yung number 0 over here, these are languages na medyo pa-extinct na or like not too much resources. Ibig sabihin, they're not properly digitized, wala masyadong unlabeled data, and at the same time, wala rin masyadong labeled data. So sobrang onti lang ng resources. And then you have things like number 5 na natawag natin na high resource languages kasi they're very well expressed in the web. You can like scrape them if you want to, and at the same time there's a lot of like people who have dedicated time to label these data sets. Tagalog and Cebuano actually falls under number 3, it's not a bad place to be in, no, but still kind of still in the middle. We do have a lot of unlabeled data. So for example, maraming Tagalog speakers, if you look at, let's say, Twitter or Reddit, but only few of this subset like were labeled. Hopefully the goal is like to bring this to number 4 or number 5. I think that would be super cool, right? Um, sorry, next slide. So if you're like building a name entity recognition data set, there are hopefully like three things that you wanted to show. Um, Hopefully open access siya. Second, it's high quality. And third, at least yung tag set niya is general purpose, like the Connell tags, which I'll be explaining later. No? Um, so first, open access, no license restrictions. Hopefully something you can use for free. I think that would be super awesome. Second, high quality annotations. What does that mean, diba? If they're annotated by humans, hopefully they have high annotator agreement. That's a good indicator of quality. The competency of the annotators, are they native speakers, or if they were annotated by another model, were they like verified, or were they double checked? And finally, their general purpose, so that it gives good foundation for further fine tuning. Because sometimes you would have like data sets that are too focused on a specific task and they're not easily transferable. It's not that it's bad, but it's just that ideally, if you, for me, for example, in the line of research I'm doing, I like building a few of these like general purpose, even kind of task specific pa rin, pero like at least the tag set can still be fine tuned, or you can still do transfer learning on another problem or another domain. Um, I want to show a few data sets, then put them in this Venn diagram. We have things like Wikian. So Wikian is very interesting because you can download it from Hugging Face, open access. The tag set is general purpose. The main problem is that the quality of the annotations aren't that good. The way they were generated was, I think they have like a rule set that they obtained from Wikipedia, and then they automatically annotated the some text using that rule set or using that model. So the problem here is that if you look at the Tagalog annotations, the first five examples may mali na kagad. So sometimes some of the places or tag as persons, and then the other way around. As in, it's quite obvious na minsan may mali dun sa Wikian. Then you actually find a lot of data sets that fall under like being open access and like being high quality. Big sabihin, they were annotated by native speakers in this definition. Meron yung storytelling NER. I think meron din span-based NER na madami. So there's actually quite a lot. But again, if you wanted to like transfer these like text into like another domain, it's kind of hard because it's very much made on these types of things. And then finally, you have some data sets like Lorelei, as far as I know, which are high quality. And to be honest, I haven't double checked it, but I know it's high quality because they were annotated by native speakers DAO. And then they're using a general purpose tag set. But the problem is that you cannot access them unless you're part of like what they call LDC, or the Linguistic Data Consortium. So for example, for me back then, I was doing some of the research independently, and if I want to access Lorelei, I need to pay like a high amount of money in order to just access that data set in a subscription-based manner. So it's kind of hard. So maybe for you, if you're interested in these types of like high quality expert data sets, maybe the institution has access to that and you can like use it. But the problem again is that Lorelei is, like it really require it, you need to jump through a lot of hoops in order to like access these types of data sets. So again, there's still a big gap, but it would take some work. So what we did is that we developed like TLUnified-NER. It's a high quality NER data set. This is actually a slide from a previous talk. Some features is publicly accessible. They're high quality annotations, coherent and complete text examples. So some of the texts were actually based from Ma'am Shari and Blaze's work on TLUnified. The domain is very much varied. So hindi lang news reports marami rin. May mga manuals din ako nakita, which I think is quite nice. And we're using like a more general tag set. So kaya siya general tag set, ito yung person, organization, location, which is based on like Connell, which I think right now is kind of what we use as like a standard way to like do like NER programs. Um, the on your right, you would see like some data set statistics, and then if you can, I'm not sure if you can see it in the slide, but um, on the background is actually like the embeddings of the entities. So it's just quite interesting as a visualization, and you can just download this in Hugging Face. In the next few slides, I want to talk a bit about how we built this. So we developed the corpora in an iterative process for 18 weeks. So instead of annotating everything in one go, we kind of like batched the examples and annotated them for a set number of rounds. So medyo matrabaho talaga siya. This process lasted for at least like 5 months with seven annotation rounds in total. So ano ba yung annotation round, right? One round for us consists of 3 steps. First one is like we annotate the examples. So I hired some annotators from Upwork and then plus me, and then we use Prodigy's annotation interface for labeling. And then after like annotating for quite some time, we kind of like did a retrospective. So after a sprint, we did the retro and then like discussed like disagreements in the annotation. So medyo may onting analysis na rin dito. And then for each round, we also like measured the inter-annotator agreement. And then we also like plot the training curve just to see if we already have enough annotations. The goal here is just to check if I train a model from the current data set that we have, if nag improve pa yung accuracy, then that means maybe adding more examples would help. But if we see that the accuracy is already like plateauing, then I guess we're already good, or maybe more wouldn't help a lot. So those are like our kind of like cut off. So if the accuracy is plateauing, or if we're running out of money, so all those things. And then finally, we update the annotation guidelines. This means like clarifying some misconceptions, improving like removing ambiguity from the guidelines, etc., adding more examples, expanding the definitions. And then one thing that I wasn't able to show here is that for at the end of this step, we also try to re-annotate some of the examples that we find weird from previous batches. So for example, in Prodigy, we have a way to like flag these instances, and then after discussing and we get to know more about the task that we're annotating, we just re-annotate them para at least like it's still high quality. And hindi lang yung mga bagong batches yung um, like high quality. Hopefully it's more distributed in the end. So we also like computed for the inter-annotator agreement, not just like the final one, but also like for each round. Um, this chart here shows like how we computed it. So for example, we followed like this very interesting paper by Branson. What he did was quite nice. His paper was actually quite nice because he's doing like name entity recognition for archaeological entities. So it's very task specific. And then he has like this section dedicated for like how do you compute like inter-annotator agreement for NER. It's a very tricky process, but I think like it's nice to like look back into to the literature and how they do it. Um, Usually kasi the solution in literature is to compute the kappa on all tokens. But sometimes like the annotators, di ba, we label the spans instead of individual tokens. So minsan nagkakaroon ng parang tinatawag natin na word alignment problem. Another issue is that, for example, if you have a text, not all of them will be annotated, right? The remaining few will have like this label called O, and usually it would outnumber the actual entities. So if you kind of like compute the total number of like unannotated versus annotated, magiging imbalance siya. So that would actually like bias your annotator agreement. So we did like some different adjustments for the Cohen's kappa para at least like it's very representative of what we want to do. And then we also computed the F1 score just to kind of like F1 score for like, so there are 3 annotators, me, 2 others. Then I just did a pairwise, then get the average of them just to have like a complete set of metrics. Another thing that we want to double check with the NER dataset is to check if it's like learnable, right? So we want to check if like, okay, we've done this, is it actually useful? Diba? So we tested on like 5 different model configurations in like a supervised learning setting. And the main difference between them is basically like the type of word embeddings they employ. This is not necessarily like a comparison between these different models, but rather to provide hopefully useful baselines for other researchers to follow. So we have things like from static vectors. We also have things like a transformer-based context-sensitive vectors. Basically, all the standard things that you can do for like token classification. Then we have like a different way. We have like different flavors of the Roberto model. We have like the monolingual Roberta from Blaze, and then we also have like the multilingual Roberta models, like the XLM and the multilingual Birch, which are like the standard multilingual Roberta models that you can use. And on the right, you will see the benchmarking results. There's actually nothing surprising from these numbers. The monolingual Roberta works well, but for us, I think the important thing here is that it's learnable, right? It's a very learnable task. Um, and then, as you remember, we also we one data set nga is WikiAn. So we actually want to double check, like, is it better than WikiAn? It's actually a hard problem because you're comparing against like a quote unquote bad data set. So what we did was we took like a subset of WikiAn and then we re-annotated it just to be sure na okay siya, perfect siya. And then we trained the model from WikiAn, tested it on ours, trained the model on ours, tested it on WikiAn, and then you can see the results below on like different models. At the same time, on the right table, you would also see like the kind of like the overlaps between our corrected annotations versus like that of WikiAn. So you can actually see how good WikiAn is, right? So for example, in terms of identifying persons or name of people, it's actually quite good, 67, 68%, quite nice. But like in terms of identifying organizations and locations, medyo hirap siya. We weren't able to check why models trained in WikiAn aren't as powerful. I guess it's just really like the annotations are not really that perfect. So for this like bullet point, yeah, NER is just one piece of the puzzle, right? NER is one of those core NLP tasks, pero ang dami pa, di ba? You have things like dependency parsing, and there are data sets for that. Like you have the tree bank for Ugnayan, the tree bank for TRG, hopefully more in the future. But you also have other tasks like question answering. You have like the self-supervised learning for pre-training. And then you have things like information extraction for text classification, etc., etc. I guess like this slide, I want to show na there's still a lot of things that can be done. Like first, in terms of coverage, like do we have enough coverage for most NLP tasks? I think the answer is no. Right now, we're focusing on NER, but there's still other NLP tasks that still requires a lot of resources. How about like in terms of Filipino languages? Right now, the NER dataset that we've built is mostly focused on Tagalog, and there are still a lot of languages in the Philippines, so it's still not perfect. Um, this is like one effort that I've been collaborating with, and the goal here is to actually like pool different like data sets from Southeast Asia. So it's a good way for me to like check, okay, may data set pala na ganito. Wala pa palang data set na ganito. But I think one important thing that we did here was we did a lot of evaluation. Like how can we reliably evaluate large language models on like Filipino? I think another question that might be relevant, maybe if, for example, if you're thinking about your research, is that is there already like a Filipino benchmark? Like how can you answer the question? Is it good in Filipino already? Because the you need to ask which tasks, which data sets, which instances do you need to consider for evaluation? And what should that benchmark contain? So yeah, so I guess like for this slide, this shows na yeah, NER is nice. We have this data set, but there's still a lot of things that can be done. We're just solving one task out of many, and I think we can still improve the NER data set as well if we want to. Okay, I'll be going on the second bullet point, but if you have any questions, feel free to let me know. The second bullet point is artisanal NLP resources. They're capable of doing a few things, but they can actually do them well. And here I want to talk about calamanCy, which is the open source library that we've built. So back then I was working on Spacey. It's a very useful tool for core linguistic tasks like dependency parsing, tokenization, NER, basically everything that most linguists will are using right now. But it mostly works well in high resource languages. So we have like this model bank, and they only contain like languages in English, Spanish, Dutch, German, mostly high resource European Western languages. So what most people do, what I've observed, is that they fine tune like the spacey pipeline or the spacey architecture in their own data. So you would find things like Daisy for Danish, Hugh Spacey for Hungarian, very interesting stuff. I've also seen some work on like Lord of the Rings related entities. They call it Hobbit Spacey. There's also things on like ancient and medieval languages. So there's one called Latin C for Latin, and then this one over here is like a paper that I had like this year. It's about ancient and medieval languages. So like I tried to fine tune spacey on these data sets. So Coptic, ancient Greek, Latin, Old French, very exciting work. And then there's also actually another spacey pipeline for Greek. So it's quite interesting. And then there's also like people who fine tune spacey on different domains, like scientific text and medical domain. So given all of these things, it led me to think, why not make one for Tagalog? And because of that, like calamanCy was born. So it's pretty nice. So I want to talk a bit about how I built calamanCy and like what are the things that can actually be done more after that. And like what are the challenges that I encountered and like what are the things that can be done after that. So, siguro a few recap muna whenever a few things just to have the same vocabulary. Whenever I say spacey pipeline, I meant this one. Think of this more as like a series of functions. And like each function, what they do is that they identify key linguistic features in the text. So, tokenization looks for the token. So, given a text, the tokenizer looks for the tokens, the tagger looks for the parts of speech tags, the parser looks for the dependency relations, NER looks for name entities, etc. And then at the end, you have like this doc object that contains all those linguistic features. So whenever someone is building a spacey pipeline, there are two things you have to think about. The first one is like the vector representation, diba? How do you represent that text into like numbers? So for spacey, this is kind of standardized already, requires minimal tuning. Basically, you can use like transformer-based context-sensitive vectors. This is outdated. People say it's high accuracy, slow to run, but I think with the machines that we have right now, it's actually quite good already. Or the lexical-based word vectors, like the typical fast text, etc. If you remember them, they're kind of low accuracy, but they're way faster to run, or they're more efficient. I guess the important question here, and I think the hardest part, is which data to use for fine tuning. Like in order to train those functions above, what data would you feed it, diba? So for the first version of calamanCy, getting this data is actually quite hard to do. Um, I'm just gonna show these three things and show you like what types of data sets I used. For the tokenizer, it required a lot of like super manual curation. So I curated some Tagalog data from parts of subsets of the original TL Unified. There's also like the Filipino slang normalization dataset by LJ Flores, which is quite interesting. And I also created some parts of it. I've also used the Tagalog tree banks like TRG and Ognayan, not just for the tokenizer, but also for the tagger and parser. And then the NER, I use the TLUnified-NER, the one that I discussed earlier. So interestingly, my when I was built when last year I was actually the final goal was really to build calamanCy, and then like the NER dataset was more of a byproduct of that effort na. So narealize ko na okay, kulang pa pala tayo ng NER dataset, and so I need to build like this one dataset in order to finish this bigger project. And then for vector representations, it's very straightforward. You have like the transformer models. Luckily, we have things like Roberta Tagalog. Then for the word vector models, there is a fast text set of vectors for Tagalog, which I was able to reuse, but I retrained them using Spacey has this like what we call the floret vectors, which is like a more efficient way of like representing fast text models. So yeah, if when you see floret, just think of fast text. So, okay, before I answer that question, so again, like the idea here is to just feed different data sets. And it sounds easy right now looking back at it, but these are very like time consuming things to do, right? So the question is like, is all that effort worth it? Whenever I ask this question, I often remember this meme. Wait, do you see it? I often remember this meme, right? Like on this part, like, oh no, you can't just mix up all these things and like call an LLM, or like, hey man, you can just call LLMs, no worries. It's very interesting. It's still an interesting dichotomy, I think. But yeah, I guess the answer here is yes. Sometimes it pays to make artisanal NLP models, and I'm gonna show you in the next two slides. Um, Turns out, um, like if given like a very task specific model like calamanCy, which is kind of like super trained on Tagalog, it actually performs well against like some of the most common like large language models that we have right now. So we have, but again, I'm comparing this in like 7 billion parameter models. Now we have things like Nemotron, which is like 340 billion, or sabi nila, after Llama 3, they'll be releasing a 400 billion parameter model. But at least, like if you compare like a spacey pipeline, which is just a vector table of different florid vectors, it actually outperforms even like some of these 7 billion parameter models. So if you compute kind of like the efficiency, which is like if you think about it in terms of like accuracy per capacity, then it's actually performing quite well. At the same time, we also did like a lot of baselines for different texts, for different tasks. So we did things for text categorization for NER. We also did a few for dependency parsing. This one is a bit tricky because, for example, for evaluating these things, you really have to separate. Kumbaga, you have to be careful of not like training on your test set, especially for NER and for dependency parsing. So it's very important to kind of like remove these things. And then finally, um, and then I also like compare. I'm not sure if you can see it in the on the table, but what I did here was, aside from like running this on like on the transformer based pipeline, I also compared it on like the best cross-lingual equivalent that you can use based on the ethnologue. And I also compared it on like some of the multilingual bird models, and it is very competitive with respect to those. So it's quite nice. So this is like, so for this like bullet point, I think there are many opportunities to do more things and do them well. Um, if you remember, I want you to remember this like axis, this four quadrant thing between model centric and data centric and task specific and general purpose, because in my opinion, there's definitely a lot of opportunities in like building things that are general purpose, still on the general purpose side, or still veering on the task specific side, but it's still very in tune with like the data sets or the language that we have right now. And I will be explaining this one later on, this slide later on, but I want you to remember this. I want you to remember like these two types of access, diba? The model centric and data centric versus like doing something that's task specific and general purpose. Right now, I actually think that we lack model centric and task specific models. And I think it's a good research opportunity because it's easier to do this because you can distill from these general purpose models. So you have a lot of general purpose models like GPT, Llama, and you can just like distill some of the annotations to build like a model centric or a task specific models. It's just a matter of like knowing what types of problems or domains are important. Just let me feel free to like interrupt if you have any questions. And then number three, not the most artisanal NLP resources. Actually, I think they're not the most mainstream, but I think they fill vital research gaps. And here I want to talk about some of the other collaborations that I've done with different other awesome researchers. I think collabs are important because it allows you to tackle like bigger problems that you can do alone. Um, right now, as I've mentioned, like building LLMs is all the rage today. Even now, like even for me, like I mean, my day job is still working on like building LLMs. And you can see here, um, the number of like language models that were built in the past year, I think, right? Like if you look at the x-axis, 1 year lang siya. Like, I mean, it's just like a 1 year gap, diba? So it's a very interesting time we're living in today. So there's definitely a lot of these models which are very exciting. Um, and that's good. Improving general capabilities of LMs is always welcome to the field. But a lot of these things, they cost a lot of money, effort, tsaka manpower, diba? So the question is like, how do you contribute to the field if you are quote unquote like GPU poor? There's one, the option A is like continue building resources but doing them at scale, right? So I want to talk a bit about Universal NER. It's kind, you can think of this more as an extension of like the TLUnified-NER dataset that I've built, but it's more of a more ambitious goal. Diba? The goal here is to create a benchmark that standardizes multilingual NER information extraction research. um, the goal here is to kind of like follow the same dream of like universal dependencies and to kind of like make it easier to perform like cross-lingual comparisons between different models in the task of name entity recognition. Um, Set number two, again, similar to universal dependencies. And we did something similar here, which is like akin to the standardized way of using it via Connell, right? So it's person, organization, location. I think we also have a subset where we annotated like other tags, basically like other yung name ng tag. But I think it's quite useful once you have those three. Why is this important? It allows us to do like to answer questions like this. um if you don't have, for example, if you have a target language and you don't have enough resources to build a model for that language, what other languages can you use in a cross-lingual fashion? So in this chart you'll see a heat map where we tested a model trained in one language. So this is like the one in the y-axis, the source language, on the test set of another, which is like the x-axis. Again, this is very important because it allows you to do fair cross-lingual comparisons. Fair, bakit fair? Because the annotations are standardized, same annotation guidelines, hopefully the texts are the same, etc. And for example, in this case, it's quite highlighted. You would see that some languages like Basque works very well in Tagalog. There's still some limitations, to be honest. Like for example, our three banks are like super small. So for example, TRG, Ognayan, they're so small that you cannot actually that they're only useful for now as like some small test sets. But it's kind of hard to like train models out of them without like doing a lot of like curation. But I think doing these types of analysis in a larger scale across different languages is a big leap forward. Next slide. And then this is another thing that we've done, is another option that you can do, like given like again the whole LLM rage, is to figure out where LLMs are lacking. So this is one project. It's quite another big collaborations actually with Blaise Joseph Imperial and even like Dan John Velasco. And the idea here is like to have a collection of data sets from different C languages. And one interesting experiment that we've done here is to evaluate different state-of-the-art large language models on these benchmarks. It's quite interesting, di ba? Kasi biruin mo, even just having that collection or curating that data set or that data hub entails a lot of work, and it's quite helpful already. So it's very interesting. Um, on your left, what we did was we took subsets of the benchmark. So the idea here is that people would submit different data sets from their different languages or maybe from other languages as long as it belongs to Southeast Asia. And then once we have once we have those different data sets, we curate like a benchmark for natural language understanding and for NLG, natural language generation. So NLU are things like sentiment analysis, summarization. NLG is more about like text completion or text generation. And then once we have curated that benchmark, we then compare like these different models. Gaano ba sila kagaling dito sa benchmark nito? And hopefully the question that we want to answer is, people are releasing these different state-of-the-art LLMs, but how do they actually work on languages in Southeast Asia? So yun yung goal. There's some interesting findings. Um, like for example, like some LLMs that are targeted for multilinguality, they actually work. So there are things like the Aya 23 or Aya 101, which are built for multilinguality talaga. They actually work for both NLU and NLG. And they're also like language models that were built for Southeast Asian languages. I think these are called Sea Lion, CLLM. They're also competitive with respect to other models, which is very interesting. And you can actually observe the same patterns for NLG tasks. So I think that's also nice. There's still some work needed. Right now, this is a C benchmark. It might be interesting to do this in a more fine grade fashion. For example, like for just Filipino languages. Um, Usually, right now, if you wanted to check if like a certain if ChatGPT works well in Filipino, usually you do something like vibes based, right? You open the chat API and then you type something and then it shows something and then oh wow, it looks good, it reads good, so maybe that's nice. But I think having a more rigorous way of evaluating these things by having a proper benchmark might be an interesting might be an interesting research question. Another thing that we did was we looked into the quality of text generations done by LLMs. The approach here was that we first trained a text classifier that discriminates between three labels, no? Human written, translationese. So for example, there are texts that are in Filipino or like in some other language, but they don't sound natural kasi they were maybe translated by a language model, so it's not really perfect. And there's also a third category called like proper standard human translation, so translation done by actual experts. um, what's very interesting is that on your left you would see that even LLMs trained on Southeast Asian languages, for example, you can see here it's Sea Lion, they're still performing very bad, diba? Like 58, 59%, quite, I mean, sure, 60%, but still, in a way, close to random, I guess, like 10%, right? Um, there's still a lot of variance, and hopefully this can increase. I think this experiment definitely can still be improved. Right now, for GPT-4, usually now we do a lot of vibe checks if it speaks Tagalog or Cebuano. But again, like having a more comprehensive way of benchmarking that is important. Personally, I'm very interested in these types of topics kasi these things involve a lot of human evaluations. Baka hindi mo kailangan gumawa ng benchmark, baka you need to pull a crowd and then like do some what we call like preference like annotations, diba? That might be one way of doing that. It might be better to ask actual humans, diba? And do a more comprehensive human evaluation rather than pulling all these benchmarks, which I think is also important, diba? Um, Again, it's still a long way to go. A lot of like these language models, they still do not uh, generate the text that we want to read, I think. Okay, conclusions and key takeaways. I think there are a lot of ways to improve Filipino NLP and build artisanal Filipino NLP resources. It just depends on where you're interested in. There are three dimensions here. I cannot draw the third one. It's kind of hard. The first one is like between models and data, diba? Parang what types of artifacts are you excited to create? Um, do you want to build models? Do you want to build data sets? So that's very exciting. Second, are you more interested on like building towards generally capable multilingual LMs? So think of things like Aya 23. So Aya 23 was built by Cohere, and they actually had 23 major languages that they use to train a language model. They have a larger model, they call it Aya 101, which they used I think 100 more languages from the data set that they crowdsourced. Or do you actually just want to solve a specific task, which I think is very important? The third dimension is between training and evals. Are you more excited about like training models, or in terms of data, are you excited about how these training data sets relate to downstream performance? or are you more excited about like evaluating whether these models perform best on a certain benchmark? So those are things are very interesting. Um, Now I wanted to show like some interesting potential avenues for each of these quadrants. The first one is like, do we actually have like state of the art models and different NLP applications? There's a lot of domains, healthcare, social media, things like there are many tasks like sentiment analysis. Do we actually have like state of the art models on that? So that's one thing. The second is that, do current models perform well on Filipino or code switch tasks? So I've always been alluding to this, right? Maybe we need a benchmark, especially on things like NLU or NLG. The third one is in terms of like creating data, 'di ba? Like which domains still lack data, especially for Filipino. I think there's a lot of things, 'di ba? For example, like yung in natural language inference or things like common sense reasoning, kulang pa. Most of these things are actually in English. One data set that you can check is yung TIDQA, TYDIQA. It's a data set na multilingual evals for question answering, and maybe we can like follow something like that, but for Filipino. And especially like for Filipino has a lot of like cultural nuances that maybe some of these benchmarks or some of these data sets don't have. And another thing for this other quadrant is that, do our pre-training data truly represent how we use our language? Um, and if we want to build a larger pre-training data, where do we need to source those texts, diba? Which websites? Sa news websites ba? Sa Reddit ba? Sa Twitter ba? Can we actually curate them? And another question is that, how about the licenses? Are there like specific things that we have to avoid, etc., etc. So those are like some of the different ways that you can actually like contribute in terms of like building artisanal Filipino NLP resources. And actually, this is my last slide. So if you have any questions, feel free to let me know. Um, yeah, so this is the last slide.